Let's call this thing 2, and this one 1. The composition of 1 and 2 looks like this. First, you take the symmetric group by F into the general linear group, and then you compose this with the determinant homomorphism to R star. Now what's the image in the kernel? The image is not all of R star, because the image of F was not all the matrices here. It was just the permutation matrices. And we saw that the determinant of a permutation matrix is plus or minus 1. So the image is the subgroup plus or minus 1 inside of R star. And the kernel, now we have a kernel. See, the original map here had no kernel at all. But now we have a kernel which consists of the sigma such that the determinant of f of sigma is equal to plus 1. Those are sometimes called the even permutations. They're not everything, because tau is not an even permutation. This little transposition is not even. But that's a normal subgroup of Sn, non-trivial normal subgroup, and it's called the alternating group on n letters. We're going to see pretty soon that its order is half the order of Sn. So its order is going to be n factorial divided by 2, at least when n is bigger than or equal to 2. The order of An. We're going to prove that pretty soon. Yeah.
I was wondering, did the notion of the sign of a permutation arise from this, or this is like the...
So yeah, this is very good. This, because there's a potentially circular argument here. If we've already used the sign of a permutation to define the determinant, this is a little illegal. So no. You have to define the determinant independent of the formula for it. Namely, you have to define the determinant as the unique map, which takes this to this, and multilinear, etc. All right, then... No, it's a good point. It's a good point. Then you have to prove to yourself that the determinant of a permutation matrix is plus or minus 1. And then you have the notion of the sign of a permutation. That's the right way to define a sign of a permutation. The other ways of doing it, you can find in algebra books the definition of a sign of a permutation. The sign of the permutation, by the way, is the sign of this determinant. This is called the sign of the permutation sigma. So for example, this transposition has sign minus 1, and the identity element has sign plus 1. Another way of doing the sign of the permutation, which is completely independent of matrices and determinants, is to prove that any permutation can be written as a product of transpositions, and that the number of transpositions is not unique, but whether they're an even or an odd number of them is unique. And that allows you to define the sign. I wanted to do it this way so that you could see that composing two homomorphisms gives us another homomorphism. Whereas this had no kernel, now we have a kernel. Whereas this one was surjective and had all of the group as the image, now we have a non-trivial image. But a good point. I mean, one could get caught up in the circularity of this. I assure you, you can do it without.